If we continue our analysis of that vector that we used when we resolved the initial velocity into vertical and horizontal components, we find that we have a vector of 100 meters per second, and I think it was launched at 30 degrees to the horizon. Now, one of the first things you could be asked after the resolving of the vectors, or the initial vector, is to find the maximum height obtained by the projectile. Now, the maximum height is going to occur at the top of the trajectory here. Let's let that position A. There's a couple of things you need to remember at that maximum height. The ball, if you look from the end, the ball has come up, or if the projectile has come up, slowed, and then stops at the top and comes back down. So at the very top there, we can say that the vertical velocity, the velocity in the up direction, is instantaneously at 0. That's the first thing we got to remember when we're doing this style of problem. Now, also you need to know when we talk about time of flight, or sorry, not time, the maximum height, we are talking about the vertical dimension. So we are going to be working in the vertical dimension, so our subscripts are going to have the subscript of y attached. Okay, so let's now think about what we know in the vertical dimension. We know that the acceleration, like any projectile here on Earth, is under the acceleration of gravity, which is 9.8 meters per second squared, and always directed straight down, hence the negative. We are trying to find Sy, so we'll put a question mark there just to orientate ourselves with the problem. Sy is going to be equal to that distance there. That is the maximum height from the horizontal line. So question mark for that one. We've just discussed that the Vy is going to equal to 0 meters per second. Uy is equal to u sine theta, which equals 100 sine 30 degrees. This comes out to be 50 meters per second up. So, what have we got there? We've got a u, a v, s, and a a. Now, from the three equations of motion that you have to learn, you should be able to select one of those, and the equation you need to check, or select in this case, is the one that says v squared is equal to u squared plus 2as. Now, applied to the y dimension, we have vy squared is equal to uy squared plus 2ay sy. Substituting those values in, we have 0 squared, it's going to be 0. We have 50 squared plus 2 times 9.8 times sy. Now what we're going to do now, we're going to move this whole expression over to this side by minusing both sides by that. The minus sign becomes a positive when you bring it across. We're going to times out the 2 via the 9.8. So we'll get positive 19.6 times sy is equal to 50 squared, which is going to be 2500. Divide both sides by 19.6. We get 2500 divided by 19.6, which is equal to 127.55 meters up. So that there is your maximum height obtained, which is up here 127.55 meters. Okay, so now we've obtained the maximum height reached by the projectile.